Okay, so back with question 4. Question 4 is also a relay ladder logic diagram, but for starting and stopping the laser engraver. So we want to be able to start and stop the laser engraver inside that shroud. When the proximity sensor inside the laser engraver sees, so this is my PRX2, my laser engraver is my LSR, I believe I've numbered it 7. But when the PRX sensor, the prox sensor inside the engraver sees the catalytic converter, both doors are closed, and both doors are closed. Okay, we have some door interlocks to identify when those doors are closed. Okay, and so when there's switches are closed, that's identifying the doors are closed. The laser engraver and the yellow laser on light should turn on for 15 seconds. So we have another timer, and we have 2 outputs in addition to the timer. We have the laser and the yellow indicating light. After 15 seconds, they should turn off. Assume the closing of the engraver doors are controlled by another process, which we did previous in question 3. So let's look back at the diagram or the schematic of the layout. And so we have our laser engraver here, LSR7. We have our inside prox sensor, RX2. And then we have our door interlocks, DLK1, door lock 1, door lock 2. And those are just switches that when the doors are closed, those switches are closed. When the doors are open, those switches are open. So that's a way to confirm that our doors are in fact closed. The situation here is that we do not want to laser engrave while the doors are open. The laser is dangerous if it hits people either on the skin or definitely in the eyes, and so we want that shrouding to protect around the engraver, similar to how you should have shrouding around when you're welding. And so looking down at this diagram, again, we're going to start with our output. So we have a couple outputs. We have the laser engraver, and I can start with my rails, or my rungs rather, my power and neutral. And we can talk about black and white as our 120, right? So that's 120 volts between those two, as we would understand a B and a W for color coding and wires at this point in the semester in voltages. So we have our laser engraver. So I have my laser engraver, LSR7. And so that's an output. So I'm drawing it as a circle, similar to how we would draw a relay coil or a motor. That's a load and output. And so of course, I'm drawing first all my outputs. Those are at the end of the day, those are the things we need to turn on and off. I have a yellow light. And the lights have these lines on the outside, getting that there's illumination. And those turn on and off together, right? So those come on, laser and light, on and off together. So whenever that's the case, I can put those parallel. Those are going to happen together. And this is LT1. I believe so. Let's look back up at the diagram here. We have indicating yellow, that's LT6. So let's make sure we clarify our lights, because that's important, because that's identifying which one is going to turn on. And then we have, of course, our timer, which is going to control the 15 seconds of this system, of this engraver being on and off. So I'm going to do timer 2. I had a timer 1 above, so let's do timer 2. So we are clear on it's a different timer because it's part of the same system. And the other thing I have is 2 door interlocks and 1 prox. And I can do a couple things here. I can draw out here my two door interlocks. And they're going to be, we draw those normally closed. And then when the door is open, they're going to open. We could also draw them normally open. The doors are going to really be the thing that defines whether they're on or off or open or closed, right? So this is DLK1, DLK2. Make that a nice L. And those go in series because either one of those is going to say that the door is open. Doesn't matter which door is open. If either is open, then I have an open scenario. I want both closed to be able to turn on this laser engraver. I also want to see that proximity sensor, right? So I want to be able to see that I've sensed the product. So when all of those things are true, oops, then I can engage, that's proximity 2 because it's on the inside. So once I have the door interlock 1 is closed, door interlock 2 is closed, and the proximity 2 sensor is engaged or sees closed, then I can turn things on. But then I only turn things on for a certain amount of time. So again, this now is the logic that I want to leave up to you, okay? But again, we have our inputs, we have our outputs, and we did those first, and it doesn't really matter what the logic is for the outputs. We know we need all those outputs. When we start putting the inputs in, we kind of need to identify how those interact with each other, right? Because they're in this scenario, they're all AND logic, so they're all in series. But then how we interconnect the groupings of inputs with the outputs. And there might be some additional contacts, timer contacts, relay contacts that we might need to add. That's where maybe the last step is. And so I would encourage us to approach these questions like this. We read the theory of operation wording, and we identify what are our outputs, write those first. What are our inputs, write those second, make sure we have our power rails. And then how do we interconnect those? That's where we have to think a little bit how the logic will function, right? How we want the logic. And we can go back to the industrial controls lecture videos and go back to some of the logic gate structures of AND logic, OR logic, NAND and NOR, the truth tables, to really start breaking down the wording and referencing that and transferring that into a schematic. Okay, good luck. Hopefully this was helpful.